Hello and welcome to another one of D's ADD videos. Today we're going to look at the concept of isotopes illustrated through a few examples. Here's the first one. Element X has two stable isotopes. The first one has an atomic mass of 10. The second one has an atomic mass of 11. This can be referred to as isotope abundance or relative abundance. Either of those words may be used. So the first one's 96% of the time, the second one's 4% of the time. How do we solve the average atomic mass? Well, all you got to do for that is you got to do the formula, summation of n, fraction, n, weight, n. So how do I go from a percentage to a fraction? Well, you just take your 96% and divide it by 100. Oops, sorry about that. And that's going to equal 0.96 and 0.04. So those would be your fractions. So if you take 0.96 times the weight of A, which was 10, plus 0.04 times the weight of B, which was 11. I gotta grab my calculator, which is, I loaned it out, didn't I? So, since one of my students has my calculator, let me bust out my phone. Utilities, there we are. And we want to do 0.96 times 10. Well, actually, you should have been able to do that in your head. Is 9.6, right? Plus 4 times 11 is 44 with 2 decimal places. Would be 0.44. So I actually did not need a calculator, did I? I was just being lazy, as most of us are. So here, when you add them, you're going to get a 10.04, and that would be your average atomic mass. All right. Let's look at another example. Here's a real-life example. Chlorine has two stable isotopes. If you were to look on the periodic table, the way you get this molar mass, aka average atomic mass, is by looking at these two stable isotopes of 35 and 37. So we have these as the actual masses of those isotopes. This is the atomic mass of 35 one and the atomic mass of the 37 one. This is the relative abundance. Again, this word could have been isotope or isotopic. So the first one's 75.8%, the second one's 24.2%. Well, again, you just repeat the formula. Oops. I think this might be my last video. Getting a little tired there. So we have fraction of n times the weight of n. So in this case, it's going to be the 75.8 as a fraction is going to be 0.79 or 0.758 times the 34.969 U, and then the 24.2, it looks sloppy. Actually, this is a decimal now, so we had to divide by 100. This is what happens when you skip steps, right? 24.2 times that mass, which is 36.566 U. So if you were to do that, let me get my phone back into calculator mode. You would get, let's see, 0.758 times 34.969, 34.969. That one gave you 26.506, and then plus 0.242 times 36.566 gives you 35.355. And I actually rounded these a little bit, so that's why we're not exactly at the 3.543 that we expect on the periodic table. If you were to look at chlorine, see it's 35.453. That's what I get for rounding these values right here. The actual value is 36.9659. If you want to redo the calculations just for exact purposes, 9659 U's, and this one is 34.9689 U's. But you should understand the concept more importantly than these details, and that's how you get the weight on the periodic table. Okay, so I hope these these examples have cleared things up for you a little bit. Make sure you practice, and check out the more advanced example in which you're going to be asked to find the actual isotope abundances versus the average atomic mass. Thank you, and have a nice day.